Watered down, we should be able to perform dilution calculations. Understand that dilution is a process that decreases the concentration. And we should also understanding that diluting cannot change acids to bases or bases to acids. Okay? So that's what we should get out of this. So, get this down. So what dilution is, it's a process that you decrease the concentration of something by adding something else. Normally, listen up. Normally we're adding water. So the good example is if you've ever made orange juice from an orange juice concentrate or lemonade from frozen lemonade. So when you have that lemonade that's frozen, it's highly concentrated, listen up. And then what do you do to make it so you can drink it? What do you add? You add water to it. So you're diluting the sourness of the lemonade so that it's palatable. So that's what dilution is. You're increasing the volume by adding more water, therefore decreasing the concentration. So the equation in the relationship is M1V1 is equal to M2V2. M stands for molarity, V stands for volume. M1 is my starting molarity, M2 is my final molarity. V1 is my starting volume, V2 is my final volume. Okay?
How do you, when you have a starting volume and a final molarity, where does that even come from?
It'll become apparent in a second, okay? So, and this is one of the things that I use all the time. All right? So, why does this work? And this is a key thing here, guys. So, the molarity triangle is the moles per liter. Molarity is equal to moles equals moles over liters. So think about it. If I increase this number here, if I make my liters bigger, let's say, if I increase this number and my moles are the same, what happens to the molarity? If I'm dividing by a bigger number, the number gets smaller, it decreases. That's why. Okay, because I have the same amount of lemonade, it's just dispersed more. There's more volume. Okay? So let's say that I start with 0.1 liters. 0.1 molarity solution. So answer this question real quick. Okay. So one starts with 0.1 liters of a 0.1 molarity. This is the volume. Remember, this is molarity. That's what the capital M stands for. So I have my moles is equal to, let's go back to the triangle for a second. Moles is equal to molarity times liters. Got it? Got that over there, guys? Okay, I'm going back. So I have 0.1 liters times 0.10 moles per liter. So I have 0.001 moles. Can you guys stop talking? It's so annoying when I want to hear blah, 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 whenever I'm trying to teach. So annoying, and it's disrespectful because I'm disrespected and everyone else is trying to pay attention. It's distracting. So the pH of this substance is equal to the negative log of the molarity of that, of 0.1. You guys can plug that in your calculator, but that number is equal to 1.
Wait, what does it say at the end? It's like equal to
0.001 moles of H+. I'm not going to help you after school if you're talking in class. There's no reason why I should use my time, because that's my time, I do it. I want to, but put me in a spot where I feel like it's okay. You're not wasting my time.
Oh, it's fine. Thank you.
Okay? So, going forward. So what we had is, we had 0.1 moles per liter. So, and we had 0.010 liters. So this is what we have here. Let's say that this represents 3, 4, 5, 6, 7, 8, 9, 10. Let's say this represents how many moles I have. And how many moles is it? It was 0.001 moles. So let's say I dilute it to a volume of 0.1 liters. I add 0.09 liters. So let's say that this volume is 0.100 liters. And I have the same number of moles. So I just have it so that the particles are more spread out. So my final molarity, I still have 0.001 moles in now a new volume of 0.1 liters. So my final molarity is 0.0001. That's not right.
So now you can figure your final molarity. How do you help the moles?
Use the triangle. So I had 0.01 molarity. That's my new molarity here. Because I have 0.001 moles divided by 0.100 liters. And I can calculate my pH of that number.
Okay, so in order to figure out your pH, the next question you have to figure out the final molarity of the reactant.
Yep.
Okay. I was just confused with why you needed the final molarity.
I'm going to show you guys the easy way to do it in just a second using the equation, but it's important. So let's do this example problem together. So one has 500 milliliters of a 0.050 molar solution of an aqueous potassium chloride. If 1,500 milliliters of water is added to it, what's the final molarity? So I want to go through these problems, and I want to identify what I'm starting with and what I want to find what I'm ending with. So what I have to start is I have 500 milliliters of something. What is that property? That's my volume. This is the volume that I'm starting with. V1. Yes, hold on one second. Let me go through it. One has of a 0.050 molar solution. What is this one? It's easy because it has the M. It's my starting molarity of an aqueous potassium chloride. Okay? So identify what it is. My V1 is equal to 500.0 milliliters. My M1 is equal to 0.050 molarity. So, of an aqueous potassium chloride solution. If 1,500 milliliters of water is added, so what am I doing to this? I'm adding that much water. So I'm adding 1,500 milliliters. So what's my final volume? If I start with 500 and I added 1,500, my final volume would be what? 2,000 milliliters. Okay, and I want to know what my M2 is. What is my final molarity? What is M2? Okay?
So I need to go log of.
Nope, you don't have to do that. We're actually not trying to find the pH. We could, actually, this is not a pH one because it doesn't have hydrogen or hydroxide ions. So what we have is my relationship. My M1 V1 is equal to my M2 V2. And that's the equation I'm going to be using. Okay? So my M1 is 0.05. My V1 is 500 equals, we'll call my M2, that's my variable I want to solve, times my final volume, which is, we just calculated, V2 is 2,000. So I can calculate this number, and why don't you guys do that real quick? So what I have here is my product of this number is 25. So I have 25, that's 0.05 times 500 is equal to M2 times 2,000. And I can just solve for M2 by dividing both sides by 2,000. And I get 0.0125. And that's my final molarity. M2?
This is the easier way to do it?
Yep. So that's my final molarity. All right? So these are the problems that this is the style of problem we're going to be doing in our homework. So we'll go through this. Maybe we'll do this one as a warm-up next class. But one thing I wanted to do is, before we pack up, the pH of water is 7. Pure water has a pH of 7. If we add water to acid, the pH will go up, but it can never get above 7. So, same thing with base. If we have a base, the pH is greater than 7. If you add water to it, it'll get closer to 7, but it can never actually get to 7. Okay? I'm just going to jump up to finish real quick. So, in an acid, always have more H+. In a base, always more OH-. This is review stuff. So adding pure water can never change if you have more acid or base. So that's it for today. Let's take a look at our objectives. Yep.